Hello everyone, I am Mohan Naik, EEE Department, Assistant Professor, Marri Laxman Reddy Institute of Technology and Management. And today I am going to discuss the topic DC Theorems. So in this DC Theorems, first we discuss the Thevenin's Theorem. First we discuss the statement of the Thevenin's Theorem. In any linear bilateral network consisting of n number of independent sources and n number of passive elements, the entire network can be replaced by a single source in series with a single circuit called Thevenin's equivalent circuit. For example, a network is consisting of a network. Network is nothing but it is a combination of the circuits. Circuit is a closed path which consisting of active and passive elements. So this network is consisting of n number of sources and n number of elements. This entire network can be replaced by a single source called VTH and in series with the resistor called RTH. So this circuit is called as Thevenin's equivalent circuit. Thevenin's equivalent circuit. Thevenin's equivalent circuit. So the entire network can be, any given network can be simplified as a single source in series with the single resistor. That is a Thevenin's equivalent circuit. So the application of Thevenin's theorem is we can simplify a complex network. A complex network can be, a circuit can be simplified as a simple network, and we also use it for power calculation and load current calculations. These are the applications of the Thevenin's theorem. And next. And procedure for the Thevenin's theorem. For any given circuit, the procedure is first of all we identify the load resistor from the given circuit. Identify the load resistor. For example, if the given circuit is consisting of a 3 resistors and a single source and load resistor. This load resistor is called RL. This resistor R1, R2, R3. This is a given circuit. So in this circuit, the first step is identification of load resistor. Load resistor, name it as A and B. This is a load resistor RL. And remove this load resistor. Step 1 is remove the load resistor. We can remove the load resistor and redraw the circuit. After removing the load resistor, the circuit will become, the remaining circuit is this one. This is R2, R1, R3, and this is V source. So this is step number 1. Then step number 2 is find the Thevenin's voltage across the open terminal A and B. Wherever the open circuit is, wherever we remove the load resistor, across the terminals A and B, we need to calculate the open circuit voltage. That open circuit voltage is called as Thevenin's voltage. So already we removed the load resistor and name it as A and B is the open terminals A and B. And R1 is the resistor, R2 another resistor, and R3 is a third resistor, and this is a V. Now we are finding the voltage across the open terminal. That voltage is called as V Thevenin's or V open circuit voltage. That is also called as open circuit voltage. Step number 3. Find the RTH across the open terminals. Find the RTH across the open terminal. While we are calculating the load resistor, then the sources can be replaced with their internal resistances. That means if any voltage source is present in the circuit, that voltage source can be replaced with the short circuit. Why? Because the internal resistance of the voltage source is 0 or equal to 0. If any current source is present, that current source can be replaced with their internal resistance. That internal resistance value is R equal to infinity. That means if all the current sources are replaced with a open circuit. If any voltage source is present, that can be replaced with a short circuit. Any current source is there, then that can be replaced by a open circuit. In our given circuit, this voltage V is the voltage source is present. So voltage source is present. So this voltage source can be make it as a short circuit replace. Why? Because their internal resistance value are equal to 0. Resistance 0 means it is a short circuit. And for current source, internal resistance are equal to infinity. That means it is an open circuit. So this voltage source can be replaced with a short circuit, and then we calculate the R Thevenin's across the open terminals A and B, RTH, R2 and R3. Now calculate the Thevenin's resistance, total resistance. To calculate the RTH, the resistor values R1 is parallel with the R3, then it is series with the R2. Value will give the RTH value. Then the step number 4, draw the Thevenin's equivalent circuit with the combination of Thevenin's voltage and Thevenin's resistor are connected in series. This value is VTH, that is the equivalent voltage source, and the resistor is connected in series, that is the Thevenin's equivalent resistor. So this circuit is called as Thevenin's equivalent circuit. Thevenin's equivalent circuit. And at last again you add the removed load resistor, that is RL. We can add the removed load resistor at last. Then find the load current value by using the formula IL equal to VTH by RTH plus RL. IL equal to VTH by VThevenin by RThevenin plus RL. Why? Because these two are connected in series. So this is about the procedure of Thevenin's theorem. Up to now we discussed the Thevenin's theorem statement. According to Thevenin's theorem, in any linear bilateral network is consisting of n number of sources and n number of resistors are replaced by a single voltage source in series with the single resistor called Thevenin's equivalent circuit. And procedure for Thevenin's equivalent circuit is: first, for any given circuit, identify the load resistor and remove that load resistor value and name it as open terminal A and B. And step number 2, find the open terminal voltage, that is VOC. It is also called as Thevenin's voltage. It is also called as Thevenin's voltage VTH. Then step number 4, find RTH, that is Thevenin's equivalent resistor. While we are calculating the Thevenin's equivalent resistor, all the sources are replaced with their internal resistances and resistors. If it is a voltage source is present in the circuit, that voltage source can be replaced with the short circuit. If any current sources are present, that current source are replaced with the open circuit terminal. Open circuit. Why? Because the current source internal resistances are equal to infinity, and for voltage sources the internal resistances are equal to 0. Then draw the Thevenin's equivalent circuit, step number 4, and then we again add the load resistor across the open terminal. Then find the load resistor value IL equal to VTH by RTH plus RL. For example, a circuit is, the given circuit is here V equal to 10 volts, voltage source value is 10 volts, and R1 is 2 ohms, R2 is 2 ohms, and R3 also 2 ohms, and load resistor RL value is 2 ohms. Then find load current, that is current flowing through the load resistor RL by using Thevenin's theorem. Thevenin's theorem. This is a given question. For this, we follow the procedure and we solve the load current value, that is current flowing through the resistor RL. The step number 1 is, for solution, step number 1. First of all, we remove the load resistor. remove the load resistor RL. That means this resistor is removed in the circuit. If the circuit is not, if the in the circuit is load resistor is not mentioned, that means the question is the current through any resistor means that resistor itself it is considered as a load resistor. So when the condition load resistor is not mentioned, then the resistor at which we find the current, that resistor is act as a load resistor itself, right? So step number 1 is remove the load resistor RL. Remove the load resistor RL. Then redraw the circuit again. The given circuit will become R3 equal to 2 ohms, R1 equal to 2 ohms, and R2 equal to 2 ohms. And these are the open terminal A and B. And source voltage V equal to 10 volts. Source voltage B equal to 10 volts. Then step number 2. Find Thevenin's voltage VTH across open terminals A and B. Wherever we removed the load resistor, across that open terminals, we need to calculate the Thevenin's voltage. The given circuit is this one. So we need to calculate the open terminal voltage VTH or VOC, open circuit voltage across, or VAB. This is also same as VAB voltage. This is R1, that is 2 ohms, R2 2 ohms, and R3 it is also 2 ohms, and V equal to 10 volts. The voltage across the open terminals A and B means the voltage across the R3. Both are same. Why? Because it is an open circuit, there is no current will flow from the open circuit, the current is 0, so this resistor value is negligible. So the remaining circuit is only 2 resistors, both are connected in series, and this will become A and B terminal after negligence of this resistor, neglecting the resistor value of R2. And this R3 resistor is R3 equal to 2 ohms. Now VTH and V equal to 10 volts. First you calculate the total current. This resistor value is I equal to 2 ohms, R1 is 2 ohms and R3 also 2 ohms. Then find total current first. Total current is V total by R total. So V total value is 10 volts, given voltage is 10 volts, and R total is, these two are connected in, these two resistors are connected in series. So 2 plus 2. So 10 by 4. The current is 2.5 amperes. Total current is 2.5 ampere is flow through the given circuit. That is a total current. So this circuit is a series circuit. So in series circuit, current is same. There is no change in the current. So the current through the R3 resistor and current through R1 resistor both are same. So here across the R3 resistor, the current is I is 2.5. So only unknown is VTH. So VTH equal to total current I into R3. That is I into R3. I value is 2.5 into R3 is 2. So total voltage across the open terminal is 5 volts. Then VTH equal to 5 volts. Thevenin's voltage is 5 volts. Then step number 3, find RTH from the given circuit, for the given circuit. Step number 3, find RTH across open terminals. The condition is, if any voltage source is present, if any voltage source present, replace the source with open circuit. Short circuit. If voltage source is replaced with short circuit, Voltage source is replaced with short circuit, and current source is present, that is replaced with open circuit. In this given circuit, voltage source is present. So this voltage source is replaced with short circuit. R1 is 2 ohms, R2 2 ohms, R3 also 2 ohms. So now you calculate the total resistor across the A and B terminal called Thevenin's equivalent circuit, Thevenin's equivalent resistor. So RTH is equivalent value, R1 is parallel with R3. This total value is in series with the R2. So what is the R1 R3 values? 2 and 2. So 2 into 2 by 2 plus 2 plus 2. So 4 by 4 plus 2, that is equal to 1 plus 2, it is 3 ohms. Now step number 4. Draw the Thevenin's equivalent circuit. That is VTH. That VTH value is 5 volts. In series with the RTH. RTH value, what is RTH? 3 ohms. RTH value is 3 ohms. And at last, add a load resistor, removed load resistor. Add load resistor. That R value is this one, R L equal to 2 ohms. These two are connected in series. Now step number 5. Find load current. There is asked load current through the load resistor. Load current, that is IL equal to VTH by RTH plus RL. VTH value is 5 volts. Substitute the values. VTH value is 5 volts. RTH is 3 ohms. And load resistor value is 2 ohms. So 5 by 5, it is equal to 1 ampere. So load current is 1 ampere. So in this way, we are calculating the load currents across any resistor in the circuit, and also we can reduce the circuit size, we can compact the size, and these are the advantages of the Thevenin's theorem. A large network can be replaced with a simple circuit with the Thevenin's equivalent circuit. Thank you.